So imagine you're a software engineer and you are maintaining a code base and you developed a new context. I don't know, a Claude Code skill, for example. How do you know if it's effective? How do you test it? I'm Max, research engineer at Tessl, and today I'm building an evaluation platform for agents. What it means is basically we want to allow to evaluate the performance of any agents, of any model in different code bases, in any code base basically with any context. Make it an appropriate proprietary code basis or open source code basis, making evals available for anyone so that you can build benchmarks. And my talk will be about the main concepts, like the main building blocks of such a platform, in case you want to develop something like this yourself or reuse some of those blocks, and why it's hard and what are the main challenges, and so on. Specifically, we'll cover like in three things. First of all, why evals matter today, because it's a very hot topic. Every frontier labs talk about evals. Second, again, like what are the core concepts, what are the main building blocks, and third, how we approach this at Tessl, because we're building such a platform, and how can you use it and integrate in your code base if you're interested. Cool, but before we dive into specifics, I want to make sure that we are all on the same page and we all understand what does it mean to evaluate an agent. So I want to have a quick quiz. Please raise your hand if you know or think you know what does it mean to evaluate an agent. Okay, opinion split. Most people decided not to raise a hand. That means that my next slide will be super useful because it's actually a definition. More or less formally, evaluation or eval means that it's a test for your agentic system. A test means it input a task, like a prompt. Agentic system, in our case, will be always coding agent, like Claude Code or Codex or whatever, which takes this prompt, a task, runs it, generates a solution. It might be a file, it might be a full application, but then on top of it, there is a grading logic, like verification or unit tests or rubrics or LLM-as-judge, which decides whether it's a good solution or not. So you get a signal whether your input was successfully processed and you get a meaningful result, or something doesn't went well. It's important to note that evals is the core concept of machine learning applications in general, but no one cared about this before the era of the LLM. It was only in the research environment, only the people who worked on papers. But now, immediately, like frontier labs market their new models based on the results of the evals. So immediately it becomes a hot topic, and every time we see something is released, big labs mention the benchmarks and evaluations. And I'm talking, right, like recent GPT 5.4, when they released a new model, the first thing which was on their main page was comparison of the new model with the previous one against some of the benchmarks where they said, hey, we improved the capabilities. Again, I'm not joking. Sonnet 4.6, when it was dropped, they launched like 20, that's just like a quick preview of benchmarks showing, hey, our new model is better than our previous generations, but it's also better than other vendors. And Vivian, in her previous talk, like mentioned that Google recently dropped Android benchmark to specifically assess the capabilities of how agents perform in the Android applications. So evaluations are driving opinions about how good are the models, how capable they are, and sometimes define whether the people will use the model or not, but it's a different story. But the next important thing is that, okay, big labs marketing or promote their models through these benchmarks, but like, for me, as a consumer of the model, does it matter? Like, does it matter to have a custom eval? If I ask you, like, imagine you had a benchmark specifically for your code base. Does it resonate with you? Does it like feel like it's something which you would value? And it's another time for another quiz, like to raise a hand if you think so, yes or no. Please respond. Okay, actually, most of the people are convinced that it's true, but I have another slide to convince even further. Depending on what role you have in your team, the reason for why eval matter for you in your day-to-day might be different. So imagine you're a software engineer and you are maintaining a code base and you developed a new context, I don't know, a Claude Code skill, for example. How do you know if it's effective? How do you test it, right? So the only way to do it reliably without vibes is to actually have some reproducible evals. Like, let's go into the next level. If you're a VP of engineering and you're caring not about one code base, but about your whole organization, you want to understand where the agents are failing, right? To understand like what are the main bottlenecks and what are the main like problems with the agents. So you're caring about the whole aggregation, and the only way to know to this is, you know, get evals. Even further, for example, a new Chinese lab dropped a super capable open source model, and it's cheaper, it's faster because it's open source, and you are making a decision, do you want to swap your expensive vendor model with this or no? How do you answer this question? The only way to do it is like do some reliable tests. Okay, assuming I convince you that evals matter, we will continue with this belief further in the talk. The next piece of the talk will be about, okay, what are the main building blocks? How to build such evaluation platform. And the very first building block of it is to decide which school of thought do you accept. Are you on the going with the vibes group, who are like every time new model is released, every time someone writes something on Reddit, decides to, okay, I'll jump to a new solution, or you're ready into a systematic, you know, evaluations and studies and monitoring, so you're ready to invest into analyzing how the models perform over the time. So it's a fundamental question, because if you're in the first team, then probably it's okay for short-term solutions when you're just like indie developer, but when you're talking about the organizations and long-term investment into the agents, it's hard to drive your decisions based on the vibes. Anyway, people are doing this. The second thing is to understand the purpose of your eval. Evals are unique because they try to assess specific aspects, and you as the person who wants to create such evaluation suite needs to understand what will be your goal. Again, it depends on what's your target, but I have like a couple of potential goals depending again on the role. If you're IC, then probably you're interested in the degree of automation and complexity of the features which your agent can do. And that's why you develop lots of context, like skills, and you want to measure how good they are. And the only input data you need for this is to create this skill and then have some greenfield environment where you can run your agent with access to this skill to solve the problem. If you're like want to have a general understanding of how agent performs in the code base, then probably you want to use the historical commits data to derive the tasks and see the performance by replaying the historical commits. It will give you a high-level overview of how complex features in your code base are. Or if you want to, again, like monitor the org level interactions of engineers with agents, probably you can use the logs and derive the actual edge cases from the human logs of how people are interacting. So now you define the goal. The next thing is to actually build this eval. And building the eval means that you need to have some structure, some unified format of your tasks and how to run them. The format of the task usually will include at least 3 things. One is the prompt itself, like what you need to build. The second, some Dockerfile environment where you define some installed dependencies and what is available for the agent in the beginning, and then tests, like how to test it. And then you need to wrap it up to be able to run it in a reproducible way. The Docker containers are usually the easiest way to do it, but there are options. Cool, so now you have goal of the benchmark. Now you have like task and now you can run the agent against this task. The key part is to understand how to judge the solutions. And the truth is there is no one single answer. Instead, there are a couple of options. Depending on your capacity and the size of your evaluation, you can go with one of three routes usually. One is having a verifiable graders, where you just have unit tests which measure deterministically whether agent does the work you wanted to do or not, through unit tests, through some, running after the execution something deterministic to verify. It's fast, cheap, reproducible, but it's hard to design because it will require you to manually review a lot of edge cases, and it's hard to scale. The opposite of this will be to replace the unit tests with other agents or with other models, so where another reviewer agent will look at your task and try to derive whether it's a good solution or not. It's super scalable, right? Because you can run thousands of agents in parallel and do lots of LLM-as-judges, but it's of course expensive and it's not non-deterministic. And another problem is you need calibration. You need to give a lot of context, a lot of understanding how to judge the solution. Otherwise, it will just randomly output this is good, this is bad. And the third approach will be a human graders, which is infeasible at all for large scales, but it's, I think, super important in the early stages when you're just prototyping your eval, just to understand, just to see that your evaluation will do what you want in general and you're moving in the right direction. So for you to eyeball at what happens and encode your preferences is super essential. Once you're happy with this, the next step to balance between verifiable graders and model graders. Cool. Now you can you have task, you have agent to run the task, you have agent to or whatever to solve and judge. The next thing is to actually build trust in your scores. And here I have a very interesting anecdotal example. So it's a running of the terminal bench across different agents and different models. And you see at the bottom, the worst performing mini SVE agent, it's a 200 lines agent, which only has access to read files and write files with Sonnet 4.5. And it has 42.5% score. But look at the error bars, how big they are. In the most optimistic case, this tiny agent will perform around 50%, meaning it will match the Codex CLI performance, right? Just because the error bars are so huge, you can't make conclusions that mini SVE agent is worse than a closed-based solution. So trust in your scores, make sure that you're not over-optimized into the noise, and that you can trust what you see from the metrics. Cool, and just to wrap up, all components in one picture. You have agent harness, which in this case your Claude Code, Codex, or whatever. You have model, which you select based on the provider. You have a collection of those tasks. Again, like tasks, it's a prompt, instructions, and so on. You run those tasks, they generate the solutions, you grade them, they generate scores, and you aggregate them somehow and derive a feedback based on this. There are many more things which we don't cover, just because we don't have time for this. But again, in practice, there are a lot of things which you need to care about, like updating the evaluation benchmark, right? Because your code base evolves. That means that your benchmark should evolve as well. You need to care about how to run it at scale. If you have 100 tasks, it's infeasible to run it on your laptop. It will just die. And yeah, like what if you want to support more agent and models and so on? Like how to handle this all? It's a hard things. But we don't cover it here. And my opinion / observation is that it's actually feels complicated to build such platform on your own. And I don't imagine that, I can't imagine that any company will decide to build their own. But at the same time, there are lots of pain points that can be clustered and addressed in a reusable way. And what we hear from our customers that their pain points are usually clustering in two main cases. And that's why we recently dropped 2 evaluation approaches, which I will talk in the next slide. So the first one is task evals. Basically, it's a perfect choice for you if you have standalone context, like for example, a Claude Code skill or API documentation for a framework, and you want to understand how agent works with this. So task evals are perfect for this because they're just like standalone things. How it works, we take your context, we try to analyze it with our engine and derive a realistic scenarios of how this context will be used in a real setup. Those scenarios are like just basically tasks. And then we run those tasks in two scenarios. One, vanilla agent, where agent doesn't have access to this context which you created, and another setup where agent has access to this context. And then we compare the scores and see whether there's an uplift or instead like the score is downgraded or where there is no uplift at all. If there's an uplift, then of course it means that your context brings something valuable and agent doesn't know how to do the task without your context. But if the scores are actually degrading, then probably there is something controversial and also important for you to look into. I will show the specific realization of how it looks. Okay, I can't do it. I will do it after the presentation because I'm in the presenter mode. Okay, let's go to the next slide. Can I? Okay, the next slide is project evals. So this type of evals is best suitable for you if you working with existing code base and you're shipping the features inside this code base. For example, you're a maintainer of the Hugging Face and you want to implement something inside it, and you just want to understand in general how agent performs on the tasks specific to this repo. How would you do this? Well, project evals is one way to do so. We analyze the history of the commits in this repo. We try to derive those commits which are relevant to your goal. For example, you are curious about the performance of some specific aspects. Depending on your setup, you can provide additional context. And then we'll also evaluate with context and without, basically replaying those historical commits and seeing what's the performance in general of the agent. Is it bad? Then it means like agent on its own probably won't be able to solve the problem as it was done by a real maintainer. If the scores are high, then it means like the degree of automation of your agent is probably good. So this is a second type of eval. And yeah, basically that was the last big thing which I wanted to say. We're jumping into the conclusions. Today we covered three main things. The first one is like why evals matter today just beyond the frontier labs, but for you as well, because they give you clear guidance how to improve autonomy degrees of your agents in your code base even further. Second is like in case you want to build it from scratch, what are the main blocks, what to think about. And third, like how we do it in case you don't want to do it from scratch. Here is like a one-click production solution, which is ready for you, which we are building at Tessl. Yeah, thank you very much. Let's stay in touch. Here's a QR code for LinkedIn. Let's connect. And yeah, before we wrap up, we're hiring, QR code for the open positions, and yeah, also a QR code for the AI Native conference in case you're interested. Cool, that's it for me. Thank you very much. Ready to answer any questions.
Thank you, Max. I just got my head around reviewing skills. Now I've got to do tasks and projects as well. It just blows my mind. Any questions? Yes.
Just before we have questions, like, can I actually quickly demo what I wanted to demo? Because I have the link open.
Cool.
So the last thing which we dropped was one of the last things which we dropped was this task evals. So basically what it means, you can upload your content, your skill, and we will generate those synthetic cases. Here the example was from 11 Labs skill. They have a skill for working with the API for text-to-speech, and we're doing some like overall review and the quality of the skill, how impactful the skill comparing to have no skills. I also see that we have landed the security checks, but specifically about the evals, here you can see those synthetic cases and the performance of the agent in each scenario with and without having access to the context. So depending on the complexity and uniqueness of your you see, like here, for example, without context, agent wasn't able to do anything reasonable at all. Depending on the uniqueness and the complexity of your specific context, the value of it will be even more because agent doesn't know about this. But you want to have some, some confirmation that it actually helps. So yeah, that's what I wanted to showcase. Now I'm ready to answer questions. Thank you.
It's also worth noting that all of the evals, all the rubrics and everything are all in there as well. So it's not just, zeros and hundreds. All the text that describes all of these evals is in there as well. I think if you scroll up on the right-hand side, there's a tree view with the evals and stuff in it. I found that. Right.
Cool. Yeah, you can read it.
Thank you. When using a model grader, is it important to use a different model from the one that originally generated the data? Yeah,
so it's a very good question because there are lots of biases, right? So if you're doing the LLM-as-a-judge, like with the model which solves the problem and then the same model grades it, like different agent but same model by nature, there will be biases. There are different ways how to handle it. What we saw that anthropic models are least biased comparing to others. So it's more of a concern to other models beyond the anthropic one. But basically you can shuffle, you can try to, again, like take the frontier model of one provider and generate the specific aspects with this model to make it unbiased. So yeah, like there are no silver bullet for this. You always have trade-offs. But yeah, that's a risk. That's why you ideally want to combine both signals. One is the signal from the verifiable, like running unit tests and running some deterministic checks, and also like LLM-as-judge, because LLM-as-judge will usually give more nuanced insights. And if you can provide as additional feedback into the LLM-as-judge, the verifiable feedback, right? So like results of how the tests were running, then you are reducing this bias as well because it will pay attention to the results of running the tests rather than making its own decisions. So like lots of ways how to deal with this bias.
Thank you.
Cool.
Nice talk.
Thank you.
One question, evals are great, but they're just giving you a snapshot of what is currently happening.
Mm-hmm.
So my question is, have you played with any optimizer like GPA or anything like that? I know that it's more, let's say, focus on text,
mm-hmm.
optimize something, but
mm-hmm.
yeah, that's my question.
Yeah, absolutely. Like evals are capturing what you have in your code base at the current shape. That's why one of the big problems with evals and challenges is to build a pipeline where you can evolve in time. So your evals evolve with your code base. But also, like you need to have this optimized mechanism ideally plugged into your pipeline as well. So we at Tessl like offer not only the evaluation, but also like optimized loop. So based on the feedback from evals, we generate some recommendations about what can you do, how can you improve your context to reduce the errors. So the short answer is like, yeah, we're playing with our own optimizers. We didn't use like external solutions because we're developing like our full loop ourselves. Cool.
Sorry,
yeah.
I have the next question. Thank you very much, Max. I just wanted to quickly ask, you see for these evals where I think what's basically happening under the hood is you're spinning up an agent, you're giving it the skill and getting it to go on a code base.
Mm-hmm.
Are you using, and you mentioned like you're using like Docker to basically containerize these agents. Are you using something like the Claude agents SDK under the hood to like strap this all together, or are you literally calling Claude via the CLI and telling it to go do something? Yeah,
so basically we're using agents in autonomous mode, right? So we're spinning them up in the isolated environment where everything is prepared. It's like not risky to if they crash something, and we're mixing basically like there are like different agents pre-installed with those different modes, and depending on the specific aspect, we are can use the SDK. For example, when we want to track the activation rates, we actually want to stop early if we realize that agent decided not to pick up a skill. and we can derive this information from the SDK, because SDK, you can control everything what happens and terminate the process if you realize that agent doesn't pick up the skill. So yeah, we're like combining all the things.
Yeah, I was just going to ask, with like model graders, when you run a lot of model-based evals, it feels like it gets pretty expensive pretty
Exactly.
quickly. I wanted to know if you had any like tricks for saving on cost, I guess. Yeah.
Yeah. So during the like prototyping phase, when we're like prototyping how eval would look like, we're not caring about cost reduction at all. We want to do as many experiments as we can with additional agent reviewers on top of the evals to distill those runs into some meaningful bar plot. So during R&D phase, we don't care. During the like when we ship it to the customer, we have caching. Basically, we don't rerun if the code base didn't change, right? So you only rerun scenarios which are probably affected by the code, by the changes in the code base or like the future commit or whatever. So yeah, like mainly we try to avoid regenerating what doesn't change, what doesn't what doesn't touch the previously integrated context. But yeah, it's very expensive. That's totally true. That's why it's so compelling to switch to open source model rather than pay vendors so much. Yeah. Cool.
Yes, I have a question about evaluating science agents. So they're very open-ended agents that can solve, problems we don't know the solution for.
Mm-hmm.
So I have, multiple agents, and I want to compare them. How well are they at solving this science problem? So it's an open-ended one. I don't really have a verifiable thing. So I need to use LLM-as-a-judge. But the problem is that I don't know what judgment criteria to use because I don't know the answer myself. So I'm wondering any thoughts on. I get trajectories from each agent. So I have many of these long trajectories, like hundreds of thousands of tokens.
Yeah.
But I don't really know what how would you go about, like what criteria should one use?
Exactly. It's an amazing question. I don't have like a full answer to you because like if we don't know like what's the actual what should be the ideal response, then I think there is a combination of us looking into the problem and like trying to analyze the formula which the science agent figured out and trying to see if it resonates with our feelings and how it should work, or like spinning in parallel like lots of additional agent reviewers which we bias towards some preference which we have, like because we ideally want to observe some pattern, right? And probably if we prompt the new reviewer agent with this specific goal, it will be able to handle this, or at least reduce the search space for us as a humans in terms of like what to validate. That's one piece of how to respond to this. The second part of the response would be probably there is still a way to introduce checkpoints or milestones into the trajectories, so you can validate that at least agent did something which you expected it from it to do, like some, I don't know, so that the solution didn't diverge completely, right? So it's like not a nonsense, but it's something which follows your intuition, and you can, like, you can encode those preferences for sure, not completely, but at least like, again, reduce the search space and filter out very bad solutions. Yeah, that's my only like. If I were to do something like this, I would do it this way. Cool.
Hey, hello, my name is Arthur. I'm interested in tokens and the cost of tokens.
Mm-hmm.
I think that it's a very key point of what is going on now in programming and some approaches with AI. Could you explain some scale or maybe proportion between expenses on tokens and expenses on payrolls?
Expenses on what? Expenses on tokens and expenses on?
Payroll, like payment of human beings. I understand that the token are increasing, and so what's the proportion now? It's like 1 to 10, or maybe 1 to 1. What is going on? I think it's very interesting and it's a very important point.
Yeah, I think like economics is for us at Tessl, it's a big journey to understand what's how the economics how to make the economics work. One way to think about this is that like every evaluation will be unique depending on what benchmark you have, like what code base you have and what complexity of the task you're dealing with. For example, if you're working with UI applications, then testing UI applications is actually more expensive because agent would spend a lot of effort to spin up the application, then introduce some vision model to review that it does something meaningful, so it will be more expensive. If it's like simple like algorithmic challenges, then probably they will be on a different like scale of costs. But so far my experience was that like on average the task will be roughly beyond $2 or $3 per task for an agent to run and solve it, and beyond $1 to grade the solution. So based on this, you can probably, and these are the numbers with frontier models. Based on this, probably you can calculate how much it will cost you to run it 1,000 times, 21 days a month. In case you were to do something new every day. But yeah, like that's so far my answer.
Thank you.
It's more like 1-1, 50-50, or tokens takes more than payroll in some.
It's tricky because I don't think you could know what our salaries are.
Yeah.
I understand the question, and I think it's an unknown. I don't think it's something we can answer.
Yeah. Cool.
Any more questions? One last one over the back there.
I can't stop to do the the parallel with unit testing in software engineering. We have to write unit test, coverage, etc. And it also fits into the SDLC. So, and I think now we call it ADLC. So, do you think if tomorrow I have to implement it in my code base with all my team, would that be the same thing, like where I have like to push engineers to have a certain coverage, certain quality of evals? Like how would that work in an engineering team?
So the question is like, how would you combine like engineers with results of agent work, or maybe
How does eval compare with unit testing in the SDLC or?
Yeah. So basically, what I heard recently from one of our design partners, that they integrated the evals in the CI/CD pipeline. So whenever they ship some skill, they automatically trigger our eval to just validate that this skill brings something, right? So like task eval, for example, doesn't obviously degrade, and they don't observe like obvious like failures. That's one story, one anecdote I heard. Another would be which the setup which we currently prototyping is collaborative development, where engineer is still in the loop and engineer is guiding what the task will be and reviewing what the agent decided to implement, and verifies whether they like the outcome of intermediate steps. And basically, engineers are like in the chat mode discussing with an agent who works on task eval some aspects like, do I like it? Does it capture enough information? Do I like the unit tests? So it basically becomes a combination where you as an engineer don't write anymore, but you just validate that it doesn't like diverge. The agent doesn't diverge and doesn't come up with a sophisticated contrived task, but rather something realistic. So you are in the loop to help to create a real scenario without writing any code. You just monitor that it does something reasonable, because sometimes just like a couple of corrections is enough to help it to go from the dead loop, basically.
Wonderful. Thank you very much for your questions, and thanks, Max, for a fantastic talk. And thank you, Vivian, for your talk as well.